Hello children, welcome back to the chemistry session. In today's session, we are going to talk about Bohr's model of an atom and Bohr's explanation of hydrogen spectrum. Remember children, according to the revised syllabus, we are teaching children. So according to the revised syllabus, some topics like discovery of anode rays and discovery of neutrons, Thomson's atomic model, and Rutherford's alpha scattering experiment, photoelectric effect, black body radiation, those topics are not given in the revised syllabus. So according to the revised syllabus, we are teaching children. So let's start today's section, line spectrum of hydrogen atom. Line spectrum of hydrogen atom. Before discussing line spectrum of hydrogen atom, let us know the word what is meant by spectrum. Spectrum is nothing but it's a combination of different colors. Suppose during raining or during drizzling, we observe formation of rainbow in the north side of the sky. This is because during drizzling, when a beam of sunlight passes through the or scattered through the fine droplets of rain, then it produces series of colors or set of colors that is called as rainbow. So rainbow is nothing but it is an example of spectrum. Spectrum is nothing but spectrum is a combination of different frequency and wavelength of colors. And the study of spectrum is called as spectroscopy. Let us see line spectrum. What is meant by line spectrum? This spectrum is broadly classified into two categories, children: absorption spectrum and emission spectrum. What do you mean by emission spectrum? Emission spectrum is produced when a sample substance is heated. When a sample substance is heated or irradiated, then the sample substance absorb energy from the surroundings and get excited. Then it produce energy and it produce radiation to the lower energy levels. And when we study the emitted radiation, that emitted radiation is called as spectrum. It is called as emission spectrum, children. Here we are talking about line spectrum of hydrogen atom because hydrogen is an example of emission spectrum. So what kind of spectrum it is? A line spectrum. Line spectrum is we observe different wavelengths as well as frequencies of light in the spectrum. Spectrum is nothing but combination of different frequencies and wavelength of the radiation, children. So here we want hydrogen spectrum. So how do we get hydrogen spectrum? In previous session we have discussed about electric discharge tube. Electric discharge tube is a partially evacuated long glass tube. When this electric discharge tube is filled with hydrogen gas at extremely low pressure and high voltage condition, it produces light or it emits light. When the light is allowed to pass through the prism or diffraction grating, which produce spectrum, or when we record the radiation emitted from the cathode ray discharge tube, which has filled with hydrogen, then the spectrum produce hydrogen spectrum. This is the way we get hydrogen spectrum, children. So scientists studied the hydrogen spectrum and they have identified different levels, different series in the hydrogen spectrum. And how does hydrogen atom produce different spectral lines in the spectrum? This is because hydrogen is a simple element because its atomic number is 1. So hydrogen atomic number is 1, so it contains only one electron. This electron in the ground state. Under normal conditions of temperature, this electron is in the ground state. When the electron absorbs energy from the surroundings, it gets excited to the next higher energy levels. Let us see the spectrum of hydrogen atoms, children. It's something like this. So these are different energy levels. They are denoted by N1, N is equal to 1, N is equal to 2, N is equal to 3, 4, 5, 6, 7. So these are different energy levels, and each energy level has definite amount of energy. E1, E2, E3, E4, E5, E6 and E7, etc. These are the energies of the different energy levels. We know that hydrogen has one electron. Under normal conditions, electron is in ground state. But when this electron absorbs energy from the surroundings, then it gets excited. It excited to the next high energy levels. And the electron at higher energy levels may not be stable for a long time. Then it comes back to the lower energy levels. So during this traveling, when we observe spectral lines in the first energy level, so during excitation, the electron will be present in second level, third level, fourth level, fifth level, and next energy levels. This is based on the amount of energy absorbed from the surroundings. So electron may be present at fifth level, or sixth level, or seventh level. So when the electron traveling from the electron emitted from the higher energy level to the first level. So we can observe here spectral lines. When we observe spectral lines in the first energy level, this series is named as Lyman series. Lyman series. Lyman series is named as when we observe spectral lines in the first energy level. It's called as Lyman series. Similarly, when we observe spectral lines in the second energy level, that is N is equal to 2. And the series of spectral lines observed in second energy level, this is known as Bohr series. L is selected here, Bohr series. Similarly, partial series. Partial series means we observe spectral lines in the third energy level. It's called as partial series. Next, bracket series. Bracket series means we observe spectral lines in series of spectral lines in fourth energy level. It's called as bracket series. Next, fund series. Fund series means we observe spectral lines in fifth energy level. Here T is selected fund series. And sixth energy level is called as Humphrey series. Humphrey series means we observe spectral lines in sixth energy level. That is called Humphrey series. So scientists have observed different series of spectral lines in hydrogen atom, because hydrogen is the simplest element in the periodic table, because it resides only one electron. But the electron is not stable in the ground state. When it gets energy from the surroundings, it gets excited. And when it comes to the higher level to the lower level, it gives out radiation. So they observe different lines, different spectral lines in different series, and they named as Lyman series, because Lyman series means series of spectral lines observed in first energy level. Bohr series in second energy level. Partial series third energy level. Bracket fourth level. Fund fifth level. And Humphrey sixth level. And they also calculated wave number of this series by using the formula mu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. And one more point, children. Here Lyman series is observed in UV radiation. UV radiation is ultraviolet light. Lyman series observed in ultraviolet light. Bohr series observed in visible light. Bohr series observed in visible light. And Paschen, bracket, Funk and Umbra series are observed in IR. IR means infrared light. Infrared region of light. Here you may write the question, why there is a lot of difference, much difference between the first energy level and second energy level. This is because the energy gap between the ultraviolet radiation and visible light is much. That's why there is a much difference between the first energy level, that is Lyman series and Bohr series. So scientists have identified Lyman series in ultraviolet radiation of light, Bohr series in visible light, Paschen, bracket, Funk and Umbra series, remaining series they observed in infrared region of light. You may ask the question that how can we know that the Lyman series only observed in ultraviolet radiation, Bohr in visible radiation and remaining series in infrared region? This is because this is on the basis of wave number of the spectral lines. Based on the wave number values, how can we calculate wave number of the spectral lines? By using the formula mu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. By using the formula we can calculate wave number of the spectral lines. Wave number of the spectral lines in the hydrogen spectrum. Here mu bar is nothing but wave number. Mu bar is wave number. And what do you mean by R here? R means Rydberg constant. Rydberg's constant. It's a constant, children. Its value is 109,677 centimeter. It is the value of Rydberg constant. Its value 109,677 centimeter. What does N1 and N2 represent? N1 is lower energy level. N2 is higher energy level. See here, N1 is lower energy level, N2 is higher energy level. And N2 higher energy level. Remember, children, these series have different N1 and N2 values. Suppose let us talk about Lyman series. N1 value for Lyman series is N1 value is 1 for Lyman series. N2 value is 2, 3, 4 and so on. For Lyman series, N1 value is 1, N2 value 2, 3, 4 and so on. This is for Lyman series. Bohr series, for Bohr series, N1 value is 2 because we observe Bohr series in second energy level. That's why N1 value is 2 here. N2 values 3, 4, 5 and so on. This is for Bohr series. N1 value 2, N2 value 3, 4, 5. We observe Bohr series in visible light. Next, third series, Paschen series. For Paschen series, N1 value is 3 because we observe Paschen series in third energy level. That's why N1 value is 3 for Paschen series. N2 value is 4, 5, 6 and so on. Next, fourth series, bracket series. For bracket series, N1 value is 4 because we observe first bracket series in fourth energy level. So N1 value is 4 here. N2 value is 5, 6, 7 and so on. Next bracket series after fund series. Fund series N1 value is 5. Because we observe series of spectral lines in fifth energy level. That's why N1 value is 5. N2 value is 6, 7 and so on. After fund series, Humphrey series. N1 value is 6 because we observe Humphrey series in 6th energy level. N2 value 7, 8, 9 and so on. So N1 value tells about lower energy level, N2 value is next higher energy levels. That's why N1 value and N2 values are different for different series of spectral lines. So this is line spectrum of hydrogen atom sugar. So scientists have observed line spectrum of hydrogen atom because they have chosen simple element, that is hydrogen, because hydrogen atom contains only one electron. Under normal condition, hydrogen present electron in ground state, but when it gets excited, it travels to the next higher energy levels and it emits radiation from higher level to the lower level. During this transition, they observed different spectral lines in different series and they named them as Lyman, Balmer, Paschen, Brackett, Front and Humphrey series. This is the line spectrum of hydrogen atom. So this is today's session, children. In today's session, we have seen line spectrum of hydrogen atom. What do you mean by spectrum? Spectrum is a combination of colors with different frequencies and wavelengths. That's called spectrum. The study of spectrum is called spectroscopy. Spectrum broadly classified into absorption spectrum and emission spectrum. Hydrogen spectrum is an example of emission spectrum. It is also an example of line spectrum, children, because we can observe different kinds of lines in emission spectrum of hydrogen. So this is today's session, children. I hope you understand today's session. We'll meet in next session. In next session, we will discuss about Bohr's atomic model. That means Bohr's explanation of hydrogen atom and Bohr's limitation. This is today's session, children. We'll meet in next session. Thank you.